Good morning, children. Let us continue with the mathematics integers lesson. Okay. So last class we have learned about how to add two integers and how to subtract two integers by using the additive inverse property. Okay. So that we have learned in the last class, and we have solved some of the examples regarding the addition and regarding the subtraction. So that is clear, how to add and how to subtract two integers. If you want to add, we have three rules. Okay. If I want to subtract, I should convert subtraction operation into addition operation by using the additive inverse. Then again I need to do the addition operation. Even though if it is a subtraction operation, I should convert into addition operation. Then we can do the needful, right? So that we have learned in the last class. Now, so let us start with the properties of addition and subtraction of integers. We have some of the properties for addition and subtraction of two integers. These properties will be there for all the number systems. What is the number system we have now? Natural number system, whole number system, integers number system. Okay, so these three number system we have learned till now. Till 7th standard, we have studied natural number system, whole number system, then integers. Rational numbers we are going to study in the next classes. Rational numbers. After the integers, we have rational number system. Okay, after the rational number system, we have real number system. Okay, after the real number system, we have complex number system. So these number system will going to extend it. Okay, so if you are going for class 8, class 9, class 10, then higher classes, this number system will going to be extended. Okay, so as of now, we have studied about natural numbers, we have studied about whole numbers. Now we have studied integers. Like in 5th and 6th and 7th, these three standard we are going to study about integers. Okay, so after studying the integers, we should learn about what are the properties of addition and subtraction of integers. We have some of the properties. Like first property will be closure property. Closure property, I will explain you what do you mean by closure property, what do you mean by associative property. First property will be closure property, closure. Okay, second one will be commutative property, third one will be associative property, fourth one will be law of identity, then law of inverse, then distributive property. Okay, out of these, I think I had explained closure property and commutative property and associative property in class 6 itself. Closure, what do you mean by closure property, commutative property and associative property. These three property I had explained for integers in class 6, I think. So I had explained. So I had explained about closure, commutative and associative. Law of identity, law of inverse, distributive property I didn't explain. Some of the sums we have done it about distributive property also, but closure, commutative, associative I had explained in class 6 also. Let us overview what I had explained in the class 6 about the integers. So these properties, these 6 properties will be applicable for all the number systems. It will be applicable for all the number system, whether it is a natural number system, whether it is a whole number system, or integers or rational numbers, real numbers, complex numbers. We are going to check in all the number systems. In some of the number systems, some of the properties are applicable and some of the properties are not applicable. That means some of the properties are obeyed and some of the properties are not obeyed. Okay, some of the properties are fails in some of the number system. Say suppose, okay, so I will explain what do you mean by closure property. What do you mean by closure property? First one will be closure property, right? First one will be closed under addition. Closed under addition. Okay, what do you mean by closure property? In the sense, closure under addition. That means operation will be addition. Suppose you are going to add two integers. Say, suppose I will do it in this page. Say, take any two integers. I'll take two integers. 2, 4. I need to check whether it is integers are closed under addition or not. Closure under addition, so operation will be addition. What is 2 plus 4? Will be 6. This result, 6 is the result, right? If you add these two, this is the result. Whether this result belongs to integers or not. This 6 is integer or not? Of course it is an integer. 6 is an integer, right? That means if you add two integers, the result is also an integer. If you add two integers, the result is also an integer. That means that is called as closed under addition. You take any two integers. I'll take both are negative integers. So what is the answer? Both are negative. We need to add 6. Sign will be negative. Observe that minus 6 is also an integer. The result is integer here. Here also result is integer. You take any of the integer, whether it is a positive integers, whether it is a negative integers, or combination of both and positive and negative integer, or combination with a 0. You take any of the two integers. If you add it, then the result number is also an integer. This property is called as closed under addition. Closed under which operation? Addition operation. This is addition operation. Closed under addition operation. You take any of the integer, you add it, then the result must be a integer. Okay, so that is called as closure law. That is called as closure law. In general, we can write for any integer, two integers a and b. A and b are the general integers. A and b are whatever it may be. In integers. A plus b is also an integer. A plus b is also an integer. Okay. This is about closed under addition. Example you can take. Example 1. You take minus 10 plus 3. So what is the answer? 1 plus 1 minus. What should we do? We have to subtract it. So if you subtract 3 from 10, it will become 7. Higher value between 3 and 10 will be 10. 10 before I am having a negative sign. Minus 7 is the result. Minus 7 is also an integer. These two are integer. We are adding. We are getting a result minus 7. Of course, minus 7 is also an integer. Therefore, for any two integers a and b, this is a and b. A plus b, this is a plus b. If you add the answer will be minus 7, right? That is also an integer. This is about closed under addition. Okay. Closed under addition. What do you mean by closed under addition? You take any of the two integers. In the integers number system, you take any of the two integers. You add it. The result is also an integer. This is true for all the integers. Okay. This is true for all the integers. Now, let us observe that this is applicable for natural number system also. Of course, it is applicable. You take any two natural numbers, you add it. What is the answer? I'll take two natural numbers, 2 plus 7. What is the answer? 9. 9 is also an integer. 2 is natural number, 7 is natural number, 9 is also a natural number. Okay. You take 3 plus 10. Both are natural number. Add it. Answer will be 13. 13 is also a natural number. That means this closure property will be applicable for natural numbers also. Not only for the natural numbers, closure property will be applicable for whole numbers also. But that is not required here. Just for your information, I am telling you. We are studying about closure under addition, which is for integers. We are studying for integers number system. If you add two integers, the result is an integer or not? That is our question. That means if you add two integers, the result is an integer. So that is about closed under addition. Now, closed under subtraction. Closed under subtraction. That means here closed under addition, closed under subtraction. That means you take any two integer, subtract it, the result is an integer or not? That is the question. If the result is an integer, then it is closed under subtraction. That is, closure law is obeyed. Closure law is applicable. Closure law under subtraction is applicable. Closure law under addition is applicable. That's it. Okay. So let me take any two integers, subtract it, see the result. Okay. I'll take 3 is an integer, subtract it. I'll take another integer 7. Both are positive integer I have taken. Operation is subtraction. 3 minus 7. What is the answer? 4. 7 is highest number. Before the 7 having a negative sign. So therefore here it is negative. Right? Correct? So what is the answer? Minus 4. Minus 4 is an integer or not? Definitely it is an integer. That means closure property will be applicable for subtraction also. Okay. So integers are closed under subtraction also. Integers are closed under addition as well as integers are closed under subtraction also. Okay. So you write the general statement for any two integers a and b. A minus b is also an integer. Observe that here I am written a minus b. Operation is subtraction. Also an integer. Okay. Example. You take any of the example. I'll take minus 5. Both are negative numbers. I'll take subtraction operation. Minus 6. What is the answer? You know that. So both are negative numbers. Here I am having a subtraction operation. I should convert into addition operation. Okay. So minus 5 as it is. Convert this subtraction operation into addition operation. Then after converting this subtraction operation to addition operation, this I should write the additive inverse of minus 6. What is additive inverse of minus 6? Plus 6, right? So now it is an addition operation. This is rule 2. Rule 3. 1 plus 1 negative. One negative integer, one positive integer. We need to subtract it. If you subtract 5 from 6, answer is 1. Between 5 and 6, 6 is the higher value. Before the 6, I am having a positive sign. So therefore here also it is positive sign. Observe that the result is plus 1. Plus 1 is obviously it is an integer, right? So this is true for all the integers. You take any of the two integers, you subtract it, the answer is an integer. Okay. So therefore integers are closed under subtraction. Integers are closed under addition also. Integers are closed under subtraction. Now the question is, the same closure property will be applicable for the natural numbers also under subtraction operation. That is the question. That means you take any two integers, subtract it, whether the result is a natural number or not. You take any two natural numbers, subtract it, whether the result is a natural number or not. Let us do that. I'll take two natural numbers, 7, 4. Both are natural numbers. I'll subtract it. What is 7 minus 4? 3. Of course it is a natural number. 7 is a natural number. 4 is a natural number. Subtracted. Answer is 3. 3 is a natural number. Correct? Okay. Say, I'll take again any two integers. 5 minus, I'll take 5 and then 9. I'll subtract it. What is 5 minus 9? 5 minus 9. What is 5 minus 9? You can't able to subtract 9 from 5. You have to subtract 5 from 9. If you subtract 5 from 9 will be 4. The higher value between 5 and 9 will be 9. Before the 9 I am having a negative sign. Clear? So answer is minus 4. Clear? This minus 4 is a natural number? No, not at all. Minus 4 is not a natural number. It is not a natural number. Whether here it is applicable here, but here it is not applicable. See, if that is a closure property in the sense that should be applicable for all the numbers. I have a natural number system that must be applicable for all the numbers. Not only for two numbers, any two numbers. It will be applicable for all the numbers. Each and every number should be applicable. Whereas I had taken two natural numbers. Of course, 9 and 5 are natural numbers only. I had done the subtraction but the answer is minus 4, which is not a natural number. Therefore, that closure property under subtraction will not be applicable for the natural number system. Therefore, natural numbers, I'm talking about natural numbers. Natural numbers are not closed under subtraction operation. Natural numbers are not closed under subtraction operation. Similarly, for the whole numbers are not closed under subtraction operation. Whereas here, integers are closed under subtraction, because you take any two integers, subtract it, answer must be 1. That 1 is also an integer, therefore it is closed under subtraction. So similarly, you can check it out for whole number system, as I've checked for integer natural numbers. Check it out for whole number system. Even it is not applicable for whole numbers also. It is applicable for only integers. So what we have learned today: integers are closed under addition, integers are closed under subtraction. Integers are closed under subtraction, addition, integers are closed under subtraction. What do you mean by closed? Take any two integers, add it. If the result is also an integer, then it is called as a closed. What do you mean by closed under subtraction? You take any two integers, subtract it, the result is also an integer, then it is called as a closed under subtraction. This is about closed under addition, closed under subtraction. So in the next class, we will study about commutative, whether integers are commutative under addition or commutative under subtraction. So let us study that in the next class. Then we will go for the next property: associative property, law of identity, law of inverse, distributive property. Those properties we will learn one by one. So what we have learned today, learn it, which is very, very important for your higher classes. These properties we are going to study for all the number systems, but properties are same. Here we have taken integers. In your higher classes, you may take for rational numbers. Then after that, you can take for real numbers. After that, you can take for complex numbers. Number system can change, but properties will not going to change. Closed under addition in the sense, you have to do like this only. Commutative under addition in the sense, you have to do like that only. The method is same, only the number system is going to change. So learn these properties. Properties are very, very important. Learn these properties in your early stages, so it will be very useful for your higher classes. Any doubts, please get back to me. You can make a call, or you can put a message to me. Save my number. If you don't have my number, go to the group, you take my number and save it, and whatever your doubts, you can put it in the WhatsApp group, individual to me, or otherwise you can make a call, you can ask for any doubts. So thank you. Next class we will going to study for commutative property. Thank you.